Yes. Yeah, thank you for the nice introduction. I want to talk to you about the e-boiler that we are realizing, but I want to start with a short introduction of Chemelot. We are at the campus here, but Chemelot is basically a combination of a big industrial site and the campus. And on the campus, there's education, there are pilot plans, and the idea is that it's what developed on the campus will reach an industrial scale on the industrial site. Well, there are around 8,000 people working here, like 60 plants. We have our own harbor, we have railways, so it's pretty big. If you look at the companies that are active here on the industrial side, OCI and SABIC are the two biggest players on the site. It used to be all DSM, but DSM basically sold all its activities to these manufacturing companies. And we also have some centralized, some organizations with more centralized activities, like Brightside. Brightside is a technology center and a cooperation between University of Maastricht, Chemelot, and TNO. We have Cytech, that's a technology provider on Chemelot, also responsible for infrastructure and water treatment. And we have USG, and USG, that's the company where I work for. Well, we are the utility supplier of Chemelot, so we basically supply all the utilities like electricity, natural gas, several sources of water, several sources of air, nitrogen. It's all on an industrial scale. If you look at the volumes on the right, you see like a baseload electricity volume of around 260 megawatts. We subtract 5,000 cubic meters of water, which we deliver to the site. So it's all pretty big. We are the owner and the operator of all the utility grids. The four largest companies on the site are our owner, so we are owned by our own customers. And we have roughly 220 staff members at USG. Our main asset is basically our steam grid. And here you get an impression of the steam system of Chemelot. I cannot point, so I try to explain what you see here. But basically what you see are the big black horizontal lines that are steam grids. Steam grids on a certain steam level. For instance, on the left you see 3 bar south. That's on Chemelot South, the steam grid with a 3 bar pressure. We have steam from 3 bar until 140 bar, and we generate high pressure steam as USG, and basically that runs down to lower pressures. On every steam header, you see that customers can re-deliver steam and they can consume steam. Yes, we have a lot of factories that consume more steam than they need. They can re-deliver that steam to USG, and we transport it to another place on the site where that steam is needed. You also see that all the steam headers are connected with each other. So basically, it's one big, large connected steam grid. The red headers that connect Chemelot South and North. We have a car highway through Chemelot. On the left is the north, on the right is the south, if you're driving to the south. And those steam headers go over the highway. We have steam generation on high pressure level, on 79 bars and 140 bars. And we also have a CHP, that's from RWA, that also delivers steam on the grid. The factories that we have a net steam demand on Chemelot. So there are a lot of factories generating steam, there are a lot of factories consuming steam, but in the balance, we as USG need to deliver roughly 300 tons of steam per hour. If you look at the fuels of these boilers, you see that most of our boilers are fueled with a combination of natural gas and residual gas. And those residual gases come from the chemical companies here. Basically, they're at the end of the chemical process. They cannot use it anymore, so we use it as a fuel for our boilers. And that's a big advantage, because in the standalone situations, those companies would probably flare these gases. We made some calculations that this whole integrated system, the synergy advantage is roughly 15%. So if all those companies would be standalone, they would use 15% more energy, or 15% energy would get waste, and we also reduce roughly 15% of emissions just by having this integrated system. Now, so this is the steam balance, and then if you look at the e-boiler, this is a principal diagram of the e-boiler, and it's really a simple installation. It's proven technology. It's already more than 50 years commercially available, and it was especially used in niche markets like nuclear plants and marine sector, maritime sector. It's basically just a really big steel vessel with a water reservoir below. On the top you have a smaller water reservoir, and the water is pumped from below to above. There you have the electrodes. Electrodes are pushed into the water. You put high voltage on it, and basically water starts boiling. You get steam, and the steam finds its way out. The key element of an e-boiler is it's really, really flexible. You don't need to worry about heating up or cooling down like you need to worry about if you have a natural gas-fired boiler. Here, an e-boiler, it goes from hot standby to full capacity in less than 2 minutes. It could even be 1 minute if you wanted. It goes from minimum load to full load in less than 30 seconds. Well, if you look at the pressure levels, at this point in time, you can buy them up to 85 bars. They're commercially available. The developments go really fast, because when we start looking at these e-boilers, about 4 years ago, it was up to 40 bar that was commercially available. And it's really low maintenance, because it's just, there are not a lot of parts in it. The electrodes don't wear. So, that are the key elements of an electric boiler. So how are we going to fit these into our system? Here you have again our steam system, and what we do is we put the e-boiler there on the 26 bar steam header. What happens is that, if we have cheap electricity, cheap green electricity, we activate the e-boiler. The e-boiler starts generating steam. It pushes the steam on the 26 bar grid. And what happens is our system basically fully automatically reduces the natural gas-fired boilers. So basically what we do, we use green electricity to reduce natural gas and to reduce scope 1 emissions from our chimneys. And the e-boiler is basically the same as a big steam producer on Chemelot. Also the factories on Chemelot, the factories that redeliver steam to USG, I mean, they can trip, they can start up, and it's all handled automatically. So if you look then what the drivers are of this project, one of the main drivers, for us it's a sustainability project. So one of the main drivers is reduce natural gas and reduce carbon emissions. The impact is pretty limited because we only aim to operate this e-boiler for like 2,000 hours a year. So it's roughly 10 kilotons of CO2 that we reduce here in a year. Of course, we want to take advantage of low electricity prices. If you look at the spread between natural gas and electricity, there will be a lot of moments when there's a lot of sustainable energy in the system that the electricity price is low. Then we want to activate it. We also have a subsidy for this e-boiler for 2,000 hours a year and for 15 years. And one thing we want to capture is the value of flexibility. We really think that there's a lot of value in the e-boiler on the electricity markets, but also in our internal steam system. And also the peak steam capacity, that's an important asset for us. We, as USG, we have to have spinning reserve that if one big plant trips, that we need to immediately generate steam and transport it to where it's needed. And this e-boiler is going to help there. And also for us, it's a really important element that we pitch this as a demonstration project. We really need to get our operators to get used to these kind of installations, like hybrid steam generation, take a look at the power market, demand-side response, because we really think that will be the future on the industry and on Chemelot. Here we're talking about a 20 megawatt electric steam boiler and a 1.4 electric superheater. The dimensions are roughly, the concrete slab is roughly 9 by 9 meters, and it's around 8 meters high. So it's pretty big installation. It has 30 tons of 26 bar superheated steam, and it's connected to our medium voltage grid of 10 kV. Well, the investment decision has been made, and we also have already purchased the e-boiler, but the commissioning is planned at the last quarter next year because we have some independence with some other projects. Well, then maybe one more word about the electricity prices. Here you see that's from the Klimaat- en Energieverkenning from last year. You see here the development of solar and wind energy until 2020, and then you see the outlooks until 2030. And you already see here that the power of solar and wind power is already increasing, but the increasement will be much higher from if you go towards 2030. And if you look at the energy prices now, these are the hourly prices of 2021. And you sort them. You start with the most expensive one, and then you end with the cheapest one. And you basically here you see three areas. The areas on the left, that are the moments where there is a high demand and there's a really low generation of sustainable energy. So basically that will be in winter when there's no sun and no wind. On the right, you have the area where there's a lot of electricity. There's a high supply of electricity and a low demand. So that are the periods that there was a lot of wind, a lot of sun, and probably in the weekends. And then in the middle, you have basically the period where the natural gas-fired power plants are setting the price. So that's basically natural gas and carbon emissions. Now, if you look, this is the area here on the left, of course, where we aim with our e-boiler. We want to take a look on the forecast of wind and solar energy, and when we think there are low and interesting prices, we will operate the e-boiler. And what we think, if you combine that draft on the left with the energy prices, that area will get bigger and the prices will be further pushed down on those areas. So we think this e-boiler, there's big opportunity here to have a good project here with the e-boiler. Now then, if you some challenges that we faced here, we already started with the feasibility study in 2018. So that's almost it's more than 4 years ago. We were convinced that it was an interesting opportunity for USG because there was a perfect fit. We already know how to buy electricity. We already know how to generate steam. We have a steam system that can handle it. So we also we did feasibility study, started conceptual engineering. But the difficulty here was that it's really the flexibility value and the business case of an e-boiler was not really clear and it was not really certain. So basically we needed a subsidy for it. But e-boilers were not part of the subsidy arrangements yet, so we started with some other parties a lobby. That lobby was successful, and there was SDA subsidy too. There was SDA subsidy available. But then the problem for us was if you want to apply for SDA subsidy, you need final permits and you need commitment of your financing parties. And those both, they don't really fit into our regular processes. Because if you want to ask a permit, you need some basic engineering, and we were not ready. We were not in the basic engineering phase yet. And also, if our shareholders didn't want to give commitment because there was no final investment decision taken yet. So what you see, that was pretty difficult here, but we managed to do that. So we want to apply for the SDA subsidy, but then we noticed that also carbon capture and storage was introduced in the SDA++ mechanism, and we knew that they were really going to ask for huge amounts of subsidy to really low cost. So we really had to find a strategy here to lower the subsidy amount that we were asking, but it's a trade-off between your business case and the probability that you get your subsidy. But well, it was all, everything went good, so we got the subsidy, but it was only June 2021 when we got it, so there was a delayment in our process here, because getting the SDA++ subsidy was a boundary condition to start the basic engineering. Because if you do basic engineering, you already start using lots of resources, money, and those kind of things. Well, I have to be a little bit quick here. We are now in the basic engineering phase. We've almost finished it. And the challenges that we're facing now, the first one, availability and price of material, this is really becoming a problem. If you need cables, if you need transformers, if you can be lucky if you get a price at all, availability is really bad and prices are really high. So that's really difficult for your estimations and also for your realization. Also, congestion in electricity transport capacity. Probably you noticed that the Limburg and the Brabant grid were gridlocked. There was no more capacity available. Also, in Chemelot, transport capacity is scarce. And you really get discussions from, well, should we use that 20 megawatt for these kind of e-boilers, or should we use it for a chemical plant that helps the feedstocks transition of Chemelot? You really get these kind of discussions, and it's difficult. The good thing of an e-boiler is that it's really flexible, so you just say, well, we only put it on when the capacity is available, so that didn't stop the project here. Also, what you see, the development of the electricity grid tariff, if you look at the development next year, it will be plus 50%. The year after that, again, plus 50%. Yeah, and it's an important case of your cost, of an element of your cost. So that's difficult. And there are all kind of activities in the country to look at the grid tariffs, to change it, to make them more facilitating for these kind of projects. But they're still not in place. And also escalating energy prices, it's pretty difficult. If you have to present the business case now, if you have to present the value, what forwards are you going to use? I mean, there's really, you can't, you see gas prices from 300 to 150 in a few weeks. And yeah, that's really difficult for making a business case and for presenting it. So, last slide. The takeaways I hope you can take away from this presentation. An e-boiler is really simple and proven technology. You can buy it from the shelf. The technology isn't the challenge. For us, for USG, it has a perfect fit. We already buy electricity and we generate steam, so that's perfect. It's a double-edged sword. I think it fits beautiful into a sustainability story, because it's both, you contribute to the grid stability, and that helps the development of green electricity capacity. And also you reduce Scope 1 emissions, so you have both benefits. And also for us, we think this is the first step towards large-scale electrification, towards demand response, and towards hybridization. I think these are all elements that we will be done on a big scale on Chemelot within a few decades. So that was my story. I hope it was clear.